Hey guys, welcome back to today's video. We are working in part 2 of the meaning of logarithms, and we will just recall from our last video that this is our logarithmic function, and it is equivalent to our exponential function. We're just going to recall that this is our logarithmic equation, and it is in fact equal to our exponential function. Okay. So we're just going to jump right on in and start working with our examples here. Here we want to rewrite each equation in logarithmic form. So we have 64 to the 1/2 power is equal to 8. This is very similar to our exponential function. Okay, so in this case, y is 1/2, x is 8, and a is 64. Okay, so if y is 1/2, we're going to say this is 1/2 is equal to the log of our argument, which is in this case 8. Okay, and our base is 64. So if we go backwards, 64 to the 1/2 power is equal to 8. And this is very much what this says right here. Okay, wonderful. Okay, let's go to our next problem. So 12 squared is equal to 144. Okay, our exponent is 2, so that is our y. So 2 is equal to, we know we need the log. Now we just have to determine what is our argument and what is our base. So our argument is what is equal to, so that's the 144, and our base is the 12. Okay, and we would go backwards, right? 12 raised to the 2nd power is equal to 144. Okay, now we have 9 raised to the -2 power is equal to 1/81. Same process. Our -2 is our y. Okay, so -2 is equal to the log of our argument, which is 1/81. Right, and our base is 9. So 9 raised to the -2 power is 1/81. And our final example in this section, we have 1/12 squared is equal to 144. Okay, so our power is what's equal. So 2 is equal to. We know that we need log. Our argument is the 1/44, the 1/144, and our base is 1/12. So when we reverse it, we have 1/12 to the 2nd power is equal to 1/144. Moving on to a couple more examples. In this case, we're going to evaluate each expression. Okay. So we have the log of 4 base 2. So 2 raised to what power gives you 4? 2 raised to the 2nd power gives you 4. 5 raised to what power gives you 125? Well, 5 squared is 25. 5 cubed is 125. So 5 to the 3rd power gives you 125. The log of 7 base 343. 343 raised to what power is going to give us 7? Okay, so how can I write 343 in terms of 7? Okay, well, I'm going to use the prime factorization tree. 7 goes into 34 4 times, so it would be 28 with the remainder 6, and 7 goes into 63 9 times. And 7 times 7 is 49, so this becomes 7 cubed. So I can rewrite 343 as 7 cubed raised to the y power, so equals 7. Whoops, equals 7. Okay. If there's nothing in the power, it is understood to be 1. And applying our laws of exponents, we have a power raised to a power. We can multiply the powers. So this is 7 raised to the 3y is equal to 7 to the first power. Now with our bases equal, I can set the exponents equal to each other as well. So 3y is equal to 1. So y is equal to 1/3. So 343 raised to the 1/3 power equals 7. And if you can, I would encourage you to check with your calculator. 343 raised to the 1/3 power. Good. So we see that is in fact equal to 7. Now we have the log of 4 base 64. Okay. So 64 raised to what power gives us 4? I'm going to go ahead and do the prime factorization tree to find all the prime factors. So 64 is 2 times 32, and we know that this is 2 to the 5th power. So we have 2 to the 6th power is equal to 64. We know that 4 is 2 squared. So we're going to write everything with a base of 2. So we have 2 to the 6th power raised to the y is equal to 2 squared. We have a power raised to a power. We multiply the powers, so this becomes 2 to the 6y is equal to 2 squared. Now with the bases equal, we can set the exponents equal. 6y is equal to 2. Y is equal to 1/3. Okay, and let's check our answer right quick. 64 raised to the 1/3 power. Wonderful. It is in fact 4 right here. Great. All right, in these next set of examples, we're going to simplify each expression. But here we're really going to hone in on the relationship between the logarithmic function and the exponential function. So here's what we'll do. In the logarithmic function, wherever we see an x, we're going to plug in the a to the y, okay? So let's do that first. So y is going to equal the log of a. Now remember, x is a to the y, okay? And then in the exponential function, wherever you see a y, we're going to plug in a log of x base a. So x is going to equal to a to the log of x base a. Okay? So we're going to use this relationship here to simplify each of the following expressions. Okay? So simplify 12 raised to the log of 144 base 12. Well, it looks a lot like this one, right? You have a raised to the log of something. Okay? So by this relationship here, if it's the log of our argument, the argument is the answer. So we have a, these two are a, we have a log of our argument is the answer. So the log 12 raised to the log of 144 base 12 is 144. Same thing for our second example, 5 raised to the log of 17 base 5. Our argument is 17, therefore our answer will be 17. Okay. Our next example is x is raised to the log of 72 base x. In this case, x here is not our argument, but rather our a that we're used to seeing here. Okay. Our argument is the 72. So x raised to the log of 72 base x, when we simplify that, becomes 72. So 9 raised to the log of 20 base 3. One little piece here that we want to note is that 9 is not 3. So these two are not exactly alike. So they're both not a, but we can write 9 in terms of a 3, right? So 3 squared is 9, and this is being raised to the log of 20 base 3. Now we know that we have a power raised to a power. We multiply the powers, so it becomes 3 raised to the 2 times the log of 20 base 3, and this is equal to not just x, but rather x squared. If this 2 here was not here, then that 2 would not be there either. But because this 2 is here, because this 2 is here, this 2 also has to be there, so it balances, okay? So if this were a 3, okay, you'd have to have a 3 here. If this were 100, you have to have 100 here. If this were another variable, let's say n, then n would have to be there as well, okay? So with that, we know that x is the argument. The argument is 20. So we're going to have 20 raised to the second power, which is 400. Well, that wraps up the meaning of logs part 2. In the next video, we will be talking about the properties of logs. So join me there, and I will see you then. All right.